Good morning. I just want to let you know that everything that is on this site today or on this video is available at mrgermanis.org. I want you to have access to this. I know that we have a quiz coming up, so please take use of this or make use of this video. I'll try and make it as straightforward as I can. I want us to start today with an entry task, so please take out your notebooks and go ahead and start the entry task. Just note as you're attempting this entry task, sometimes the calculators don't have the cotangent function on them, but just remember that cotangent, another way to write cotangent is 1 over tangent. So cotangent of x is the same as 1 divided by tangent of x. So just to kind of remind you of one of those things you learned in pre-calculus, this is an accurate drawing, so please pause the video, and I want you to attempt to find the average rate of change. The average rate of change as in like the slope of the line that connects these 2 points, the slope of the line that connects this point to that point. If you want to see this Desmos live, I posted the Desmos link down here. You don't need it actually, but it is available if you want to access it in the future. So go ahead and pause the video, compute the average rate of change between those 2 points. I say that give it about 5 minutes of attempting to do it, and then continue the video, and I'll show us how to make that happen. So by this point, you should have attempted this problem for about 5 minutes. Let me go ahead and show you what I would do for this problem. I'll try and keep the picture and everything on the page. So we've got y equals cotangent between the points pi over 4 and 3 pi over 4. So this is obviously going to be pi over 4, and this is 3 pi over 4. And in order to calculate the x and the y, so my input, my x values, I'll just make a quick table. My x values are pi over 4, and my other x value is 3 pi over 4. And my f of x is cotangent of x. Well, if I don't have the cotangent function, all I'd need to do is in a calculator do cotangent of pi over 4. Or if I don't have the cotangent function, it's 1 divided by tangent of pi over 4. And whatever you get from that is what we'll be using. So if you put this into a calculator, you should get 1, which is kind of a nice number to have to be dealing with. And then if I do the other one, it's going to be cotangent of 3 pi over 4, and that, if you don't have the cotangent button on your calculator, you can always do 1 over tangent of 3 pi over 4, and that equals -1. And that kind of looks right, because 1 for pi over 4, it's up a little bit, and for 3 pi over 4, my output is -1, and it's below the x-axis. Just that kind of makes sense. If we're finding the average rate of change, the average rate of change we've talked about is the change in y divided by the change in x. So how much does the change in y happen? Well, the change in y between 1 and -1, you could use a formula, but just on a number line, the difference between those numbers is 2. So I guess if I wanted to do it with a formula, it's going to be y2 minus y1. So the y2 minus y1. So that's the change in y being divided by the change in x. Well, the change in x, it starts at pi over 4 and it goes to 3 pi over 4. So the change is going to be 2 pi over 4. But we can do that with a formula as well, in thinking that 3 pi over 4 minus pi over 4, that's just -2 over 2 pi over 4. So, I mean, we can toss that into a calculator. and we would get a number. But I'm going to try and be a little bit more sophisticated about it. I'm dividing a fraction, so I'm going to keep the first fraction, -2. I'm going to change the division here. The division here is going to be changed to multiplication, so -2 times, and change it, flip it, 4 over 2 pi. I'm going to reduce that fraction. The 2's cancel out. I have -4 over pi. And so that is our number answer. If we put that into a calculator, we would see that that is the average rate of change, or we would see that that is the slope between these 2 points. So, that didn't follow along with me, did it? Pi over -4 over pi is the slope of the line that connects those 2 points. So I just wanted to quickly talk about the learning target today. There's a lot more here than what we'll really be doing. My goal is that you understand that this idea right here, that the slope of the graph changes at different x values for nonlinear functions. But most importantly, like today, we're really going to focus mostly on being able to calculate the slope of the tangent line. So if you can use the limit formula to calculate the slope of the tangent line, then you should be good to go today. All right, I want to take just a second to remind us of some things that are coming up. The last day to retake the Unit 1 test is Wednesday of next week. I'm not staying after school. I repeat, I am not staying after school on Wednesday. So please take the time to come in and retake your Unit 1 test if you need to retake it, or if you've never taken it before, please plan on doing that for the first time. I want to make sure that you have access to that. I'm going to grade the tests during Thanksgiving break. So make sure that you're doing that. But next, but certainly not least, is that next class. This is next class. Next class. Next class, we have a derivative quiz. It's going to be similar to the practice that you see in class today. You must know how to use the limit definition of the derivative. And if you don't remember what that is, I'll just share that with you. If you do not have this anywhere else in your notes, please make sure that you have this down. We said that the derivative function f prime of x was defined as the limit as h approaches 0 of f of the value that we're interested in plus a little bit minus the value that we're interested in, f of a, divided by a plus h minus a. And eventually you should notice, oh, I'm so sorry, there's a small typo here. This should be f of a. F prime of a is the limit as h approaches 0 of f of a plus h minus f of a all over a plus h minus a. And some people really don't like having those two, so they always do cancel out. So some people say that it's just over h. Please make sure that you have this formula somewhere in your notebook, because it will come in handy again and again and again and again and again. All right, some folks had questions about the quiz. I'm hoping that this makes it really nice for you. There's going to be 2 or 3 limit questions. I'm going to make sure that they're going to be kind of algebra heavy, so just be prepared for that. 2 to 3 limit definition questions about derivatives. I should write that in. About derivatives. So they're not derivatives. So they're not just limit questions, they're limit definition of derivative questions. I'm going to let you use all of your notes, so it's an open note test. So come prepared with the notes that you have and take today in class. That will be helpful. I recognize that it's kind of early on, but this test is going to be one of the few that I'm going to have that's optional grading. So what does that mean? That means that you have the option for the grades to count or not count. If you say no grading and you do well, it doesn't count. I'm sorry, like you need to choose whether you want it to be graded or not. If you say that if you grade it and you do poorly, it still counts, even though it may impact your grade negatively. I just want to point out today that the three types of functions we're going to be using are linear, so that might be like y equals 2x plus 7, or something along those lines. Quadratic functions, which are kind of like y equals, and we'll do this one later today in class, plus 2x. And actually, I lied, and there might be a problem that has, they're called rational expressions. And they look like 1 over x plus 1, and we'll do another problem like that today here in class. So these are the three types of problems: linear functions, quadratic functions, and rational expressions. Those are the three types of problems that you'll probably encounter on your quiz that happens next Wednesday. All right, we're at the point in this class where it's going to be a lot of stopping and starting the video. Please stop and start the video as needed. This is in order to help you for your quiz next Wednesday, and it's actually probably kind of nice to review this stuff online, maybe tomorrow as homework, so that on Wednesday you can come in and just be ready to go. When you see each problem, I really want you to please attempt each exercise until you reach a stuck point. So that means look at the video, watch for the question, and then attempt the problem. When you're done or you reach a stuck point, play the video until you're unstuck again. And I'm going to have the substitute kind of measure where the class is and ask to see where you are. So play the video until you're unstuck. And then finally, when you feel like you finished or can't keep going, I want you to finish the question and check your work as you go, because the video is intended to support the rest of your learning as you go, so that you don't, so that you know exactly what you're doing and you have some examples to bring on your quiz. Again, you can use notes on your quiz on next Wednesday, so come prepared to take notes for that quiz. So I'm about to start the first problem. Go ahead and make sure that you're ready to start and stop the video as you feel that you need to. And if you're watching this video at home, now's a good time to just kind of get ready to practice some problems. So there is a worksheet that is probably going around, but if you don't have the worksheet, that's okay, because the problems are right here. I'm going to encourage you to stop and pause the video. I want you to use the limit definition of the derivative to compute the slope of the curve at that point. So what that might mean is, if we're drawing a picture for this function, it's going to look something like this. At 2, when x is 2, we've got a point there, and if I draw a tangent line at 2, what you are doing currently is computing the slope of that tangent line. So pause the video, attempt each of these problems. We're going to do the first one first, and then the second one afterwards. I'll let you know when I switch between the two, but please pause the video now, give it a try, and we'll come back in just a few minutes. All right, so at this point you should have tried the first problem at least. I'm going to kind of move the slide over for just a second in order for us to get some space. The problem was y equals x squared plus 2x at the point 2. So our function is y equals, equals x squared plus 2x minus 2x. Plus 2x minus 2x, can't remember. Plus 2x plus 2x at the point x equals 2. All right, so we have to know the limit definition of the derivative. The limit as h approaches 0 of f of a plus h minus f of a, all divided by a plus h minus a. And remember, the a and positive a and negative a always cancel out. And my a value here is 2. So I'm going to actually rewrite this entire thing. The limit as h approaches 0 of f of 2 plus h minus, I'll do that in black, minus f of 2 over h. And this is now just a composition function. So f of stuff, well, what is f of stuff? And y is another way of writing f of x. So f of x is this. F of x is f of stuff is stuff squared plus 2 times the stuff. So f of stuff is the stuff squared plus 2 times the stuff. And we'll just go ahead and rewrite it, and I'm doing it in color coordination. So the limit as h approaches 0 of f of stuff, which is stuff squared plus 2 times the stuff. Ooh, that's not a anymore, it's 2. 2 times the stuff. Okay? Minus f of 2, whatever f of 2 happens to be in red. F of 2 is stuff squared, or 2 squared, plus 2 times the stuff. And I'm using lots of extra parentheses because I just want us to be really clear about what this means. Dividing by h. Divided by h, because it's all still being divided by h. Well, now I have to expand all of this out and combine like terms. So I'm just going to work on this blue stuff right now, and this is just a number that we'll calculate in just a few minutes. But I really just want us to be good at computing this stuff. So the limit as h approaches 0 of the blue stuff, so 2 plus h times 2 plus h, and then I'm going to distribute, so plus 4, distribute, plus 2h, and then copy everything else, minus, well, we can do the stuff in the parentheses. 2 squared is 4 plus 4, that ends up being 8 anyway, so divided by h. Well, I've got to expand this out. Let's see. There we go. Expand this out. I've got the limit as h approaches 0 of 2 times 2, so 4, 2 times h, so 2h, h times 2, so again another 2h, and h times h, h squared. Now I got to deal with the 4, bring the 4 down, so plus 4 plus 2h, minus 8. That 8, I'll undo that, 8 minus 8, all over h. This cleans up really, really nicely because things start canceling each other out. And I hope you start to see what can cancel each other out. Let's simplify it first before I do that. So it's the limit as h approaches 0 of 4, I got 4 and 4, so that's 8. I got 2h, 4h, I got 6 h's plus 6h plus h squared minus 8. H squared and then the minus 8. All over h. And 8 and negative 8 cancel out. Oops, that's not what I wanted to do. Bring that. There we go. So the limit as h approaches 0 of 6h plus h squared over h. Well, hey, like we can factor out a common factor up here and see that this is equivalent to the limit as h approaches 0 of h times 6 plus h, because when I distribute that, if I were to distribute that h, I'd get this again. All of this should be over h. Well, h and h cancel out, and I'm left with the limit as h approaches 0 of 6 plus h. Well, if I were to evaluate that limit, I get 6 because h is 0. 6 plus 0 is 6. So this function evaluated is 6. That was a very big problem, and I know that it's a lot to take in. If you want to take a quick picture of this so that you can follow it along later, or you can always come back to this video, that's fine too. If you haven't yet done the second part, please pause and attempt the second problem, and I'm about to start it in about 10 seconds. So, I'm going to use the limit definition of the derivative, the limit as h approaches 0 of f of a plus h minus f of a all over h at the point 2. So a is going to actually turn into 2, and I'm just going to do it right here in the problem. So a is going to turn into, I can't do it, I guess. The limit as h approaches 0 of f of 2 plus h minus f of 2 all over h, which is the same as, I have to use this function now, 1 over stuff minus 1. So f of stuff is 1 over stuff minus 1. This is equivalent to the limit as h approaches 0 of 1 divided by stuff minus 1. So 2 plus h minus 1 minus the red stuff f of 2, 1 over 2 minus 1. And then all of that is all still over h. Well, I'm going to simplify this now. I'm going to simplify this. This is equivalent to the limit as h approaches 0 of the blue stuff, 1 over 2 plus h minus 1 is 1 plus h minus 2 minus 1 is 1 minus 1 over 1, all of that over h. And if, I should have done that in red. I'm sorry. 1 over 1 is still the red stuff. And so if I want to combine like terms, which I kind of need to do, if I need to combine like terms, I need a common denominator here. So this is 1 plus h. I can easily multiply by a funny version of 1 plus h over 1 plus h, to get the denominators to be the same. So this ends up being 1 over, here I'm gonna try and color coordinate it, 1 over 1 plus h minus 1 plus h over 1 plus h. And now we can simplify. All of that still over 8. I forgot the limit. So h approaches 0 of this stuff. Simplifying, I'm going to just go down now. This is going to be 1 minus 1 plus h, all of that over 1 plus h. Because I now have a common denominator, and then all of that is over h. Let's see if it'll let me erase. I still need the limit as h approaches 0. Trying to go down a little bit. I'm going to simplify this top fraction. So 1 minus 1 plus h ends up being, I have to distribute that negative, so I end up getting limit as h approaches 0 of h over 1 plus h, negative h over 1 plus h divided by h. Well, now this is a fraction being divided. So I have a fraction divided by a fraction. that's going to be the same as, keep the limit symbol still, h approaches 0, keep it, change it, flip it. So the first fraction, keep it, change it to multiplication, and then flip it. It's really h over 1. It's going to be 1 over h. And then I can cross-cancel. I'm not cross-multiplying, I'm cross-canceling. I have a negative h and a positive h. I have a negative h and a positive h. Those cancel out. I'm left with the limit as h approaches 0 of negative 1, because 1 times that negative 1 that got canceled out is negative 1. And then what am I left with? 1 down here. 1 plus h times 1 is just 1 plus h. 1 plus h. So as h approaches 0, this limit approaches negative 1, or negative 1 over 1 plus 0, so negative 1 over 1, which is negative 1. So this takes a very long time. These are not easy problems, but they're problems that when you are able to do them, you have a lot of power in your hands in order to do bigger problems. And we'll zoom out. Feel free to take a picture if you'd like. Sorry, I kind of went all over the paper. But we're going to try a couple other problems, and I want you to bear with me. If you're at the point where you're like, I give up, I want you to try again. One more problem, 2 more problems, and I'm confident that it will start to make sense. It's very rewarding once you start to get it. So hang on, bear with me. We're going to go to the next slide and try it out. Oh, so this is a context-based problem, and it's number 5 on your worksheet if you're using the worksheet. I'll just read it really quickly. An object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is given by the function 100 minus 4.9t squared, where the function s of t is measured in meters. How fast is the object falling at exactly 2 seconds after it is released? So I'm just going to kind of imagine this. I have an object, it's 100 feet up, it's being dropped, it's going to hit the ground. Some point in between is 2 seconds, and we're looking for the speed, the instantaneous velocity of that function after 2 seconds. So this is a quadratic function. It's just kind of disguised in a slightly different problem. We're going to use the limit definition. We're evaluating it at 2 seconds, so t is going to be 2. So our point of interest there is 2. We're looking for the slope of the tangent line to the curve at 2. Okay, so I need to use my limit definition. So the limit as h approaches 0 of f of a plus h minus f of a over h. And if you haven't paused the video to try this yourself, I'm going to encourage you to try it yourself really fast and then come back when you're done. All right, hopefully you've tried it and you're ready to come back. So we're going to use, and instead of f, we're using s. I suppose the function that we're using is s, but we're calling it f. So just know that s of t and f of t, this is just a generic formula for a derivative. So just know that we might use a different function name here. So as we go, equals the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. We've been using 2 a lot, I've noticed. And that's the same as the limit as h approaches 0 of f of 2 plus h, so 100 minus 4.9 times 2 plus h squared minus f of 2, so 100 minus 4.9 times 2 squared. All of that over h. And if you got confused here, let's highlight it out for you. This is the same thing as this, and this piece is the same thing as this. If that gives you any indicator of what we've just done. So I will just keep going as we should, right? As we're trucking along. And this is now just a lot of computation, a lot of algebra at this point. So this is the same as the limit as h approaches 0 of 100 minus 4.9 times 4 plus 4h plus h squared. And I just expanded out this, all of this in the parentheses is this, minus 100 minus 4.9 times 4. I'll put that in parentheses. All of that over h. Okay, and that's equivalent to the limit as h approaches 0 of 100 minus 4.9 times 4, so 19.6 plus negative 19.6h minus 4.9h squared, and then minus 100 minus 4.9 times 4 is, so double negative, so plus 19.6. All of that over h. It looks really big and long, but we start to notice that I've got 100 and then negative 100. I've got negative 19.6 and positive 19.6. So all I'm really left with here, h approaches 0, is negative 19.6h minus 4.9h squared, all of that over h. And I can factor out an h, so limit as h approaches 0 of factoring out an h times negative 19.6 minus 4.9h all over h. I've got this common thing on the top and the bottom. It's all being multiplied, so cancel. And I'm left with, I'll just rewrite it one more time. Some people may not need to rewrite it this many times. H approaches 0 of negative 19.6 minus 4.9h. As h gets closer and closer to 0, this gets closer and closer to 0, which cancels all of this out because h is getting close to 0, but this is left unaffected. So when I evaluate this function, it is negative 19.6. What does this 19.6 mean in the context of this problem? It means that it is falling at a speed, it is falling down. That's the negative part. It is falling down at a speed of 19.6 meters per second. So it's falling down from this tall tower at a speed of 19.6 meters per second. So that's the meaning of that negative 19.6. I think this is a very doable problem for a test. I would actually say this is a great test question because it's, it requires you to know your algebra a little bit. It requires you to know the limit definition of a derivative, and it's not super complicated. There's no big tricks that you need to know in algebra to make it work, but it is very tedious. It's very long to do. All right, I think we've got 2 more examples. One more I really want you to do in class, and then you can get some practice on your own. I do want you to pause the video now and be sure that you try here number A. I'm going to change that to red. Please do try number A. It's a linear function, and I think it's super doable. B is really challenging. B is really a challenging problem. I want you to attempt it, but know that B requires you to understand a key trick, and I'll go over it really quickly. So please pause the video, try it now, and then come back when you're ready. All right, hopefully at this point you have been able to attempt this problem. Give it a try. We're going to use the limit definition of the derivative. So the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. And I'm starting to not use the formula as much anymore because we should be starting to master it. So the limit as h approaches 0 of 3x, well, x is 1 plus h, minus 4. This stuff in blue is the same as this stuff here. Okay. Minus f of 1, so 3 times 1 minus 4. And this red stuff here is this red stuff in there. All of that over, over h. The limit as h approaches 0 of, I'm going to distribute, so 3 plus 3h minus 4, distribute, or actually we don't even need to distribute because we know this is minus 1, all of that over h. Double negatives make a positive, so the limit approaches 0. I'm going to just simplify up, so I'm thinking 3 minus 4, so negative 1 plus 1, all of this happens to this, and this all cancel out, and I'm left with the limit as h approaches 0 of 3h over h. Those cancel out, so if I evaluate the limit, it's just 3. But that kind of makes sense, because the slope of a line is 3. Think about 3 being the slope of this line, and the slope of the tangent line is 3. Interesting idea. We'll go ahead and do this last one. There's an extension question. If you know the slope of the formula for a line, you can compute the equation for the tangent line because you know a point. It's a point slope formula. If that's something that interests you and want to extend on it. We'll do B really quickly right down here. It is a little tricky. There is a trick to it, so I want to make sure that you have access to that trick. We're going to evaluate the limit at 4, so the limit as h approaches 0 of f of a plus h minus f of a over h, and we're going to go quickly and say it's not a, it's 4. It's not a, it's 4. So that's going to be the same as the limit as h approaches 0 of the square root of 4 plus h minus the square root of 4 all over h. That's actually pretty simple. What makes this tricky is that there's a math trick that you need, because remember our goal, the reason why we can't evaluate this limit as it is right now is because we're dividing by h. So we've got to somehow get rid of that h. And there's a trick to doing that. We're going to multiply by something called the conjugate. And the conjugate is just the same thing as we have here, but instead of a minus sign, it's a plus sign. So if we multiply by the conjugate, it helps out. So we're going to multiply by the square root of 4 plus h plus the square root of 4 divided by the square root of 4 plus h plus the square root of 4. And like if I'm thinking about this as like a multiplying a binomial, I can distribute this, and I will see that the square root of 4 times the square root of 4, or excuse me, the square root of 4 plus h times the square root of 4 plus h is just, and I'm going to set it up, h minus h approaches 0. The square root of 4 plus h times the square root of 4 plus h is just 4 plus h. And negative, this is going to get complicated, but just take a look. I'll try and do it in a different color. Negative root 4 times root 4 plus h is this one right here. And then we're going to do it again. Root 4 plus h times root 4 plus... Oh, that's not positive, so plus root 4 times root 4 plus h. And then we got to do that last piece, which actually counts. Root 4 times root 4 is just 4. Actually, it's negative 4. My apologies. Negative 4, because it's negative root 4 times positive root 4. So it's negative 4. But did you notice? Did you notice that this is a negative, this is a positive, they're opposites, so all of this cancels with all of that. We're still over, well, all of that cancels out, and we have h times root 4 plus h plus root 4. But I'm not really worried about this yet. I'm not super duper worried about this yet because it's all going to kind of come to play. I'm just going to clean it up. I'm just going to rewrite it in a way that makes it more clean. Limit as h approaches 0 of 4 plus h minus 4 over all of that crap on the bottom. And I don't like it, but the root 4 plus h plus root 4. Oh, hey. 4 and negative 4 cancel out. The h and the h cancel out on the top and the bottom. H, I'm left with h and h cancel out, some 1 over 4 plus h plus root 4. And then it's the limit as h approaches 0 of that. Well, as h approaches 0, this becomes super nice because it becomes 1 over, I'm evaluating the limit now, root 4 plus 0, so root 4 plus root 4. This is, what is root 4? Root 4 is 2, so 2 plus 2, so this is the same as 1 over 2 plus 2, or 1/4. Gosh, all of this work to find that as h approaches 0, like the derivative, the slope of the tangent line to this is 1/4. So I hope this was helpful. We are going to skip the next piece of this activity because if you've gotten this far, you should be ready to go for your quiz next Wednesday. Please email me if you have any questions. I will be around, or try and be as available as I possibly can be, or I'll be around during advisory tomorrow. Please come and talk to me. Thanks so much for watching. I know this is a long video, but it should be helpful for you. Here's an extra practice problem if you want it. The video is about to end, so why don't you pause it now so you can write it down.